Hi, my name is Neil Tando, and this is my constant velocity Lab 01 report. The purpose of this lab is to understand the concepts of physics principles with regards to motion. In particular, this lab aims to assess how net forces, position, and velocity are impacted by constant motion. This lab also serves to give an understanding of developing a digital model and comparing that to the real findings to create real-world applications and conclusions. In this lab, I had to create a real-life video analysis model of constant motion using the Tracker app. Using the data collected from visual analysis, I then created a computational model that resembles the findings of the tracker using GlowScript. In my experiment, I rolled a marker in the positive x direction along a meter stick from end to end. This gave me a displacement of 1 meter to use for my video and computational analysis. This data was collected by using the Tracker app to record the position of the marker in time intervals. Due to the human and app imperfections, change in position along the x-axis isn't perfectly linear, contributing to slight variations in velocity and acceleration. In this case, because the experiment is only assessing motion in the x direction, the change in position of the y component can be ignored, although that variation is very small regardless. This is the computational data derived from the findings in the tracker. I will discuss the code in more detail on the next slide, but the velocity is constant as shown in the bottom graph and positive in the x direction, contributing to a positive linear graph of position as seen in the top graph. To implement the computational model, I calculated the average velocity from the tracker data by subtracting the final position from the by subtracting final position minus an initial position and dividing it by the total time elapsed. I also set delta t to the same time interval that was used in tracker to produce that data. Lastly, because the velocity is constant, F net was set to be 0 newtons, and the velocity and position of the ball were updated according to Newton's second law. When comparing data between tracker and GlowScript, this graph shows the change in position measured by both. Although they are both very similar, the computational model is perfectly linear, while the tracker data isn't. This means that in real life, the net force wasn't exactly 0 newtons, as there were periods of acceleration and deceleration which contributed to that imperfection. Some assumptions were made in this experiment when creating the computational model. Because velocity was assumed to be constant, net force was assumed to be 0 newtons. Also, in the computational model, the displacement was assumed to be exactly 1 meter. However, in reality, there are several sources of error or imperfection that contributed to the offset seen in the previous graph. To elaborate, in real life, there are friction and air resistance forces acting on the object. Also, the tracking and/or recording could have been imperfect, contributing to slightly skewed data. Lastly, when measuring true displacement, there could be random error from the meter stick used to determine that displacement was 1 meter. So what if instead of rolling the marker in the positive x direction or from left to right, I rolled it in the negative x direction or from right to left? In that case, the velocity would still remain constant but would be negative, and the object would move in the negative x direction instead. However, the magnitude of velocity and displacement would still be the same regardless of direction. So why is there zero net force? I assumed that the only forces acting on the object were the forces of gravity and the normal force from the table. Both of these forces act in the y direction and they negate each other, so net force is 0. To maintain constant velocity in the x direction, there would also be 0 net force in the x direction, which is why friction and air resistance were ignored in the computational model. Overall, the aim of this project was to use Tracker to analyze real-world motion and convert that data into a computational model using GlowScript, thus providing a greater understanding of the applications of physics concepts, and those were all achieved. The ultimate findings from this experiment were that the computational model is reasonably accurate when compared to real tracker data, and inconsistencies that were found between the two models were due to the previously mentioned sources of error and the true net force not being perfectly 0. That concludes my this lab report. Thank you very much.